friends, so now we are going to solve a numerical which is based on the inverse Laplace transform of log term. And guys, here I'm going to use the property of Laplace transform of integral. So let's see how to apply that Laplace transform integral property in inverse Laplace transform and get the value. So here we have to find out the inverse Laplace transform of 1 upon s log of s plus 3 upon s plus 2. Now guys, to get the inverse Laplace transform of this function, if you see a term which is log. Now if you have seen my previous video, I have told you that to find out the inverse Laplace transform of such functions, we use the property that is multiplication by t property in inverse Laplace transform. So guys, before using that property, if you observe the given function of s carefully, then it is in a form of 1 upon s into some function of s. And guys, it reminds me about one of the property of Laplace transform which is called as Laplace transform of integral. So let's revise that property once again. So as per the Laplace transform of integral property, if we have to find out the Laplace transform of integral 0 to t f of u du or f of t dt, then it is given by 1 upon s phi of s. And guys, if I take this L to the RHS, that becomes Laplace inverse of 1 upon s into phi of s. And guys, that is exactly matching with this. So this is 1 upon s and I can call this as phi of s. So it means the answer of this is gonna be integral 0 to t f of t dt or f of u du. And to get that value of f of t, we have to find out the inverse Laplace transform of phi of s. So we have to find out the inverse Laplace transform of this log term. So let's start. So here this is 1 upon s phi of s. I'll call this term as phi of s. Now we have to find out the inverse Laplace transform of this term. Now guys, this term is a log term, and if I want to find out the inverse Laplace transform of log term, then we have to use another property. So you can see here that this property I have used in the previous question, which says that inverse Laplace transform of phi of s is nothing but minus 1 upon t inverse Laplace transform of phi dash of s. So this property is called as differentiation of phi of s. Now this property is applicable whenever we have this phi of s or the function of s as log term, tan inverse term, cot inverse term, or some other terms for which the derivative is possible, and for that derivative we can find out the inverse Laplace transform. So here phi of s is this log term. What I'll do is I'll find out derivative of this phi of s, which is phi dash of s, and then we'll find out the inverse Laplace transform of that derivative. Will multiply it by minus 1 by t, and we will get value of this inverse Laplace transform of this given function phi of s. So here I'll use the property of logarithm, which is log of a upon b is log a minus log b. Now let's find out the derivative. So derivative of phi of s is phi dash of s, which is given by 1 upon s plus 3 minus 1 upon s plus 2. Now let's find out the inverse Laplace transform of this phi of s. So Laplace inverse of this phi of s, which is log of now guys, this is given by negative 1 upon t Laplace inverse of phi dash of s as per the property. So this will be 1 upon s plus 3 minus 1 upon s plus 2. So guys, this is nothing but the value of phi dash of s, and for which the inverse Laplace transform is possible. So here we will get negative 1 upon t. Here in the bracket, the inverse Laplace transform of this term is e to the power minus 3t minus e to the power minus 2t. So I'm assuming guys that you all know the formula of inverse Laplace transform, and if you don't know the formula, don't worry, you have to go back and revise my video name as definition and formula of inverse Laplace transform, and you'll come to know the answer of this. Now here I got the inverse Laplace transform of this function, and that was my phi of s. Now guys, to get the answer of this, I'm gonna use the Laplace transform of integral property. So according to that property, inverse Laplace transform of 1 upon s into phi of s. Here my phi of s is log of s plus 3 upon s plus 2. Now it is given by the formula integral 0 to t f of u du. Now guys, f of u is nothing but your f of t only. In f of t, replace t with u, you get f of u. So that is negative 1 by u. Here e to the power minus 3u minus e to the power minus 2u du. So guys, this is the inverse Laplace transform of this given function. So I'm not gonna solve it because here I've applied the property and we got the inverse Laplace transform of that function. So this is how we got the inverse Laplace transform of a given function. So guys, I'm sure that you understood how I've applied the differentiation of phi of s property as well as the Laplace transform of integral property to get the inverse Laplace transform of this given function. So don't forget to share this video with your friends so that they can also get benefited, they can also understand the simplest way of solving the Laplace transform and inverse Laplace transform. Thank you very much.